Okay, this video is about implicit differentiation, and so I've provided a worksheet for you, and so I'm not going to write out all the words that you should be filling in the worksheet. I'm going to say it out loud and you can fill in the blanks. And so it says that implicit differentiation consists of blank, blank, and so what you should put in those blanks is it consists of differentiating both sides of an equation and then solving the resulting equation for y prime. That is the process of implicit differentiation. Why do we use implicit differentiation? We use it because it's much easier to differentiate an equation when it's not easy to solve for y to get it by itself. And so that's known as explicitly when you can solve for y explicitly, when you can get y by itself on one side of the equation. Sometimes that's easy to do and sometimes that's difficult to do. So for example, if you have an equation like this, what if we had maybe the square root of x to the fifth plus 1 minus y equals to 0? That would be pretty simple to solve for y by itself, to solve for y explicitly. And we can use the methods of differentiation that we already know to take the derivative to find y prime. But if they give us something like this, x squared plus y squared is equal to 25. This is the equation of a circle that's centered at 0 with a radius of 5. I hope that you guys recognize that equation. But we could, to solve for y by itself, is a little more involved. It's not horrible. We would have to solve for y equals to plus or minus the square root of 25 minus x squared. So that gave us two equations that would describe the whole function of y. So it's a little more involved to find the derivative there. Here is another case that is even more difficult to solve for y explicitly, and that is x cubed plus y cubed is equal to 6xy. To get y by itself in this situation is even more involved, and so to be able to find the derivative y prime would be a lot of work mathematically. So we have this method called implicit differentiation, which is where we take the derivative of both sides of an equation and then solve for y prime. That's what the process is. Let's see, as far as your blanks go, there on your worksheet it says, the assumptions we're making throughout this section is that y is a function of x and that y is differentiable. Those are important facts to establish throughout. When is implicit differentiation used? Kind of what I talked about. Whenever it is difficult to solve explicitly for y. Why is it used? In those cases, when it's hard to solve for y by itself, it's much easier to find dy dx. It's much easier to find y prime. So that's the blanks that I have on there. Now let's just dive into some examples. Here's example 1. And so what we're supposed to do is find dy dx, and we're going to use the method of implicit differentiation. And so they give us x to the fourth plus x squared y squared plus y to the third is equal to 5. Now we got to keep in mind that y is a function of x, so when we take the derivative of y, we have to use chain rule. Because if y is a function of x, we would take the derivative of y, which is the outer function, times the derivative of the function of x, the inside function. We have to use chain rule where that's involved. So what we're going to come in here and do is say, okay, this is the equation we were given. What we're supposed to find is dy dx. So what we do is we take the derivative with respect to x of both sides of this equation. So once we do that, it looks like this. 4 is the power rule, so it's going to be 4x to the third plus, and this, since y is a function of x, is a product rule. So it's going to be first x squared times the derivative of y squared. Remember that y is a function of x, so we take the derivative of the outside function, 2y to the positive 1 times the derivative of the inside function, y prime, plus, we're still doing product rule. So far we did first times the derivative of second plus second, y squared, times the derivative of the first, 2x plus the derivative of y cubed. This, again, y is a function of x, so there's going to be a chain rule involved. It's 3y squared times the derivative of the inside function, y prime, is all equal to the derivative with respect to x of 5. There's no x involved in that side of the equation. 5 is a constant, and so the derivative of that is 0. That background noise, as you hear, is my dog chewing up a piece of cardboard, so that's what that is. So this is the equation that we have. So what are we supposed to do? We're supposed to find dy dx. Well, if you recall the different notations, dy dx is the same thing as y prime. So all we're doing here is solving for y prime. Let's see, what terms have y prime in it? This one and this one. What I'm going to do is gather the y primes on the left side of the equation and put the terms that do not have y prime on it on the other side of the equation. How I move terms to the other side of the equations is I basically subtract them. So these guys are staying. What I'm going to do is factor out a y prime from this term, leaving me with 2x squared y. I'm going to factor out a y prime from this term, leaving me with the 3y squared. I'm going to move these or subtract these to the other side of the equation. So this is going to be minus 4x to the third. This is going to be minus 2xy squared. Now I have y prime times all of this equals this. I'm just simply going to divide both sides by all of this. 2x squared y plus 3y squared. 2x squared y plus 3y squared. This is what y prime equals to, and y prime is the same thing as dy dx. So that is example 1. Let's go ahead and have a look at another one. You get in the rhythm here and not too long. How about example 2? It says this. Find dy dx by implicit differentiation. And so they give us this one. Y times the cosine of x is equal to x squared plus y squared. And so all we're going to do is take the derivative with respect to x on both sides of this equation. So it goes like this. D dx of this side is equal to d dx of this side. So right here, this is product rule. Y is a function of x. So it's first times the derivative of the second. So it's y times the derivative of the cosine of x, which the derivative of the cosine of x is what? Negative sine x, okay, plus second cosine of x times the derivative of the first. The derivative of y is a function of x, is just going to be y prime, is equal to the derivative of x squared, 2x, plus the derivative of y squared, 2y to the first power times inside function y prime. Okay, now, so every time we see a y, we have to multiply it by the inside function y prime. I'm going to gather up my y prime functions on the left side equation. I'm going to move everybody else to the right side. At the same time, I'm going to factor out y prime. So this becomes y prime times the cosine of x, a minus 2y. I'm going to leave 2x right there because he's where I want him to be, on the right side, 2x. And then I'm going to add this term to both sides because it's minus sine x, y sine x. So I'm going to add plus y times the sine of x. Okay, and now we're going to divide both sides by this term right here. The cosine of x minus 2y, or this factor I meant to say, the cosine of x minus 2y. This right here is what y prime is equal to. So that is the first two examples. I'm just going to double check to make sure I got good answers before we move on. Let's see here. Y prime is negative 4x cubed minus 2xy squared over 2x squared y plus 3y squared. That's a good answer. Y prime down here is 2x plus y sine x over cosine x minus 2y. That's a good answer. Okay, let's do a couple of more examples. And then you'll know how to do implicit differentiation. So, here we go. The next example has an e in it. So let's look at that. It has e to a power in it. And so you just always have to keep in mind that y is a function of x. So you always have to add that times the inner function, or times y prime, when you're taking the derivative of y. So that's one of those assumptions we were making earlier. So right here, the next one we're going to do says find dy dx for this function e to the x over y is equal to x minus y. Okay, if we have to find dy dx, we look at this and say it's not that easy to solve for y, so we're going to use implicit differentiation. So we do this, d dx of this, d dx of that. Okay, so the derivative of e to the something is just e to the something, e to the x over y, times the derivative of the power if it's something more than just x, and it's something more than just x. So the derivative of x over y, this is chain rule, is a power function. So we'll say low d high, low y, derivative of x is 1, d high, minus high x d low. The derivative of y is y prime over low y squared. All right, so let's see. E to the something times the derivative of something, low d high minus high d low over low, okay, is equal to the derivative of x, which is 1, minus the derivative of y, which is y prime. We're going to solve this for y prime. The rest of this is not calculus, it is just algebra. So first thing I'm going to do is kill my fraction. I'm going to multiply both sides by y squared. That just cleans it up a little bit. So right here I have e to the x over y times y minus x y prime is equal to 1 minus y prime times y squared. I multiplied both sides of this equation by y squared. And that killed my fraction here. If you want to see it in motion, you could say, okay, y squared over 1 times y squared. I multiplied both sides by that. Right here, this canceled out, and I just got this times this. Over here, this got multiplied there. Now, the next thing I'm going to do is distribute everybody to free up these terms. So on the left, I get y times e to the x over y minus I'll just say xy prime, times e to the x over y is equal to 1 times y squared minus y squared times y prime. And so again, now I'm just going to gather up my y prime terms. Here's a y prime, here's a y prime. I'm going to get them on the left side of the equation. I'm going to move anybody else to the right side of the equation. First, I'll factor out a y prime as I do it, so it'll be y prime. If I add this term to both sides, plus y squared y prime, I'll have a positive y squared y prime right there. And then I have minus x e to the x over y times y prime. And then on the right side, I have this y squared, which I just left, and over here I subtracted this to get to the other side, minus y e to the x over y. Now I'll simply divide both sides by this factor right here, y squared minus x e to the x over y squared minus x e to the x over y, and that is what y prime equals to for this example. So let's see, let me just double check and make sure I'm happy with my answer. I said that it should be y squared minus y e to the x over y squared minus x e to the x over y, and yes, I like that answer. Okay, one more example and then we'll be done with this particular video and worksheet. Example 4, the last one we have here, is use implicit differentiation to find an equation of the tangent line to sine of x, the sine of x plus y equals to 2x plus, minus 2y. We need an equation of the tangent line at this curve at the point pi comma pi. All right, so we've written the equation of a tangent line many times. To write the equation of a line, you just need the slope of the line and any point. They came out and handed us a point, x1, y1. I'll go ahead and label that. This is the point. Okay. We need a slope. So we don't just need any slope. We need the slope not of a secant line, but of the tangent line at the point when x is pi. So we can find the slope of the tangent line in general by finding the derivative, dy dx. So the job here is to find dy dx and then plug in this point x1, y1, pi for x and pi for y, and we can figure out what the slope is, and then we'll just plug it into the point slope formula. So find dy dx. Let's use implicit differentiation. So it's d dx of this side, d dx of this side. So here we go. Derivative of sine is cosine. So it's the cosine of x plus y times the derivative of the inside, because this is chain rule, because it wasn't just the cosine of x, times the derivative of what we have inside of here. So the derivative of x is 1. The derivative of y is y prime, equals to the derivative of 2x, which is 2. Derivative of negative 2y is minus 2y prime. And so now we have to solve for y prime to find out what dy dx is. So I'm going to distribute cosine of xy to both terms. Cosine of xy times 1 is the cosine of xy, x plus y, plus y prime times the cosine of x plus y is 2 minus 2y prime. Okay, let's get our y primes on this side, everybody else on that side. So it's going to be y prime times the cosine, I need a kind of a bracket here, y prime times the cosine of x plus y, y prime times the cosine of x plus y, plus 2y prime plus 2 is equal to 2, I'm going to subtract this guy off, minus the cosine of x plus y. Now to solve for y prime, I divide both sides by this, the cosine of x plus y plus 2, the cosine of x plus y plus 2. And that is what y prime equals to. All of this is what y prime equals to. Whoops, y prime. But they didn't just say find y prime, they said write the equation of a tangent line at this point. So at the point when x is pi and y is pi. So let's plug that in. What is y prime at this point? Pi, comma, pi. Well, that's going to be 2 minus the cosine of pi plus pi over the cosine of pi plus pi plus 2. All right, now let's think about our unit circle. If you're a unit circle person, and if you're not, just think about however you figured out the cosine or the sine of where pi or 2 pi was. The cosine, okay, pi plus pi is 2 pi. So let's just, that's 2 pi. This is 2 pi. Okay. This is the angle 0 right here. And then coterminal with the angle 0 all the way around, it's also 2 pi. 2 pi. So the cosine is the x value at this point. So the cosine of 2 pi is 1. So what this really is 1. 1. 2 minus 1 is 1. 1 plus 2 is 3. This is the slope of the tangent line at this point. Y minus y1 is m times x minus x1. This is the point slope formula of a line. I hope that you learned way back when you were in intermediate algebra or middle school or high school or somewhere back there. So this is y minus y1 pi is equal to m 1/3 times x minus x1 pi. We can, if we want to solve for y, we certainly can. This is y is equal to 1/3 x minus pi over 3 plus pi. Pi over 1 is 3 pi over 3 plus negative 1 pi over 3. This is going to be 2 pi over 3, 1/3 x. This is the equation of the tangent line at that point. Okay, that's implicit differentiation.